welcome back. It is June 8th, and we're going to do our last notes of Math 8. If my dates are wrong, I am pre-recording, so I apologize. So we are going to cover surface area and volume of cylinders all in one go, which means that you might want to pause this partway through when I tell you we're done with surface area, work on those problems, and then come back for volume. So just keep that in mind. I think the cylinder is it's generally what people find simplest, and also you get to use pi, which who doesn't love that? So surface area and volume of cylinders. And just a reminder, something like even a pop can is considered a cylinder. So let's start with our surface area. You had to draw nets before when I gave you a beautiful cylinder such as this. And generally when you're given a cylinder, you will be given two dimensions. You'll often be given the radius, which is half the distance across the circle, and you'll be given the height of the cylinder. So let's roll on over to the net so that we can figure out what are all these pieces. So we have a top circle, then we have this body. Again, not to scale. And then we've got a bottom circle. So of these circles, they still have the radius. And what you'll see is that this is the height, corresponding here. This dimension here is the height. And this length is actually the circumference of this circle. So it ends up kind of wrapping around, and this is our circumference. And you may not remember, but the circumference of a circle is 2 pi r. So when we look at surface area, we have a few surfaces to consider. We have two circles, and we have one rectangle. Now for our two circles, we use that same formula that we used a few weeks ago to calculate the area of a circle, which is pi r squared. So it's going to be 2 pi r squared. And a rectangle is length times width. So we have 2 pi r squared, but we need to clarify this length times width. So in this case, the length is this 2 pi r h, or this circumference. Is the 2 pi r circumference multiplied by the width, which is the height. I got ahead of myself. So this here ends up being our beautiful formula. This is what I want you to write down at the beginning of each surface area of a cylinder question. 2 pi r squared plus 2 pi r h. So let's do an example. So let's see here. We've got 7 centimeters here as the radius, and 17 centimeters here as our height. First thing I need to do, write down my formula. This also tends to be why students find this a little bit simpler. The formula is pretty easy to use. Doesn't change up a lot. So the 2 will stay a 2. Pi will stay as pi. I will show you why I keep writing it just like this. It will make it easier and better for your calculations later on. And my radius was 7. And that 7 will end up being squared. Then that 2 will stay as 2 pi. My radius was still 7, and my height was 17. So then I'm leaving my 2 pi here. I want to figure out what 7 squared is. 7 times 7, 49. Plus 2 times pi and 7 times 17, which I know you all know off the top of your head, is 119. So in your calculators, if you have one like mine, this one here, you can make your lives easier by just using the pi button. So for example, this was 2 pi times 49. In this one, I can go 2 pi, and I can use my brackets, times 49, plus 2 pi 119. Because remember, these being right beside each other is just telling me they're multiplying. And if you have a 2-line calculator, it makes it real simple for you. And then I can just actually press enter. Now, I can also break it apart step by step and go 2 times pi times 49. And I would get my 307.88 when I round it to 2 decimals. And then I go 2 pi times 119, and there I get 747.70. When I add those two together, I get 1055.58 centimeters squared, because my units were centimeters and surface area I square. Okay. And yes, that is the same answer as when I just plugged everything in right away. So key thing for this, have your formula, make sure you have your radius and your height. Okay, let's do another really quick one, and then we'll do volume. Example 2. We're going to change up our units this time. Very exciting. If you're feeling like I'm more prepared when I'm doing the video lessons, it's because I'm not making up all your examples on the fly. I'm actually writing them out beforehand. They're on the fly at a different time. So for this one here, my radius is 10 feet and my height is 15 feet. So I need to simply start with my formula. Surface area equals 2 pi r squared plus 2 pi r h. Leave my 2 pi for now. My radius is 10. My radius is still 10, and my height is 15. Oops. So I'm going to leave my 2 pi as it was. 10 times 10 is 100. 10 times 15 is 150. Okay. Now, if I calculate this all out like I had previously in my one go, 2 pi times 100 plus 2 pi times 150 I end up with 1,570.8 feet squared, because my unit here was feet, and surface area, I square it. Now, it's okay if you have a calculator that doesn't have a pi button. You can use 3.14 instead. But if you do have a calculator that has the pi button, use the pi button. You will have more accurate answers, and that'll really help you out later on in math. Okay, let's go to the easier one, volume. So if you want to take a break, this is where to take a break. All right. Volume of cylinders is pretty quickly understood. So I will tell you how we get the formula, and then we'll do just one example. So let's draw a general cylinder. Just realizing that after this week, you're not going to get to see my drawings freshly every week, which is, I mean, really unfortunate for you. So I have a radius there and I have height. So if we recall from the last few, like when we did volume of a triangular prism, volume of a rectangular prism, we think of volume as being the area of the base times the height. A cylinder has a circular base. This looks more like a circle, so maybe I should point that one out. So when I look at my volume, it's going to be the area of a circle times height. Well, we just talked earlier, area of a circle is pi r squared, and height in this case is still just going to be height. So this is your beautiful golden formula for volume. Love it, cherish it, make it your best friend. All right, let's do one example, and then you're free. Well, at least for math for today. So let's say this radius here is 20 meters, and let's make this height here 10 meters. So first thing I want to do is I want to use my beautiful golden formula. My volume equals pi r squared h. So in this case, pi, well, in all cases, pi is just the same. It's a constant. We don't need to mess with pi. My radius was 20, so 20 squared. And my height was 10. Now, I'm going to show you like the really shortcut way if you've got a calculator like mine. And I'll show you the more long, slightly longer way. So I can actually go pi times, and just use my little brackets here, 20, and this one's got a little squared button here, squared, times 10, and get an answer. Pretty impressive. But let's do it the slower way, because some of us don't have fancy calculators. I recommend, if you can. So we've got pi, 20 squared, 20 times 20, we get 400, times 10. Then if we want to slowly do this out, 400 times 10 will give us 4,000, so pi times 4,000. Then we can just go pi times 4,000, and we get the same answer. We get 12,566.37 meters, and its volume, so we cube it. Well, I wish you all good luck. I hope this made sense. There will be ways for you to answer questions, or sorry, ask questions. That'll be included in the emails. And I hope you have a terrific, awesome, wonderful week.